Hospitals operate under a strange, almost unbreakable rule. They can almost never power down an active MRI machine. The massive electromagnet inside requires an incredibly specific, stable environment to stay online. If a hospital is forced to cut the power incorrectly, the essential cooling gas trapped inside rapidly boils off. It expands violently, bursting through emergency vents and escaping directly into the atmosphere. In the medical field, this violent reaction is called a quench. When that happens, the hospital faces a catastrophic financial penalty. Replacing the specific gas that just escaped the machine costs upward of $40,000, or about 30 to 40 lakhs. You most likely know this expensive, volatile substance as a cheap novelty to fill up party balloons. But this is helium, and today it is the highly coveted light gold of the modern world. The global supply of this light gold is quietly but rapidly vanishing. We are consuming it faster than we can find it. The shortage escalated rapidly when China quietly blocked the export of its own helium reserves. They moved to protect their internal technology manufacturing, leaving the rest of the global markets scrambling for what remains. This creates a severe vulnerability for import-dependent nations. India, for instance, relies on foreign shipments for 100% of its helium supply. Without those imports, critical infrastructure is at risk. The expense of a single MRI quench is a micro-scale preview of a much larger dependency. Because helium is essential for everything from medical imaging to satellite manufacturing, a shortage of this gas creates a potential failure point for a wide range of modern industries. Helium acts as a physical bottleneck for advanced technology because of one unique trait. It is the only substance in the universe that remains in a liquid state at absolute zero temperatures, minus 268.9 degrees Celsius. When you cool an electrical circuit to that extreme level, you hit a state called superconductivity. Electrical resistance drops to zero. Instead of bouncing around and generating massive heat, electrons move in a perfectly smooth, frictionless path. This prevents powerful electromagnetic machines from melting themselves from the inside out. This exact method of extreme thermal control is required to manufacture the delicate silicon wafers and circuits inside modern semiconductor chips. It is also the strict baseline requirement to operate quantum computing processors, which only function when suspended in an environment near absolute zero. Even aerospace launch vehicles rely on liquid helium. Their massive fuel systems must undergo cryofreezing before a rocket can safely break the atmosphere. Without liquid helium to achieve superconductivity, the core pillars of our future, artificial intelligence, space travel, and quantum tech, instantly hit a physical wall. If helium is the backbone of the 21st century, why doesn't science just synthesize more of it in a lab? The answer is simple: we can't. Helium can only be created by nature. Deep inside the Earth, deposits of radioactive uranium slowly decay over millions of years. During this extremely slow decay, the uranium emits fast-moving alpha particles. As an alpha particle travels through the surrounding rock, it steals two orbiting electrons to stabilize itself, becoming a complete helium atom. When extraction companies drill into the Earth for natural gas to make CNG, this trapped gas comes up to the surface. But helium makes up a microscopic 0.1% of that total extraction yield. Because it is the second lightest element in the universe, it has a fugitive nature. If it isn't captured immediately the moment it leaves the ground, it defeats Earth's gravity and escapes into the vacuum of space forever. Humanity's most advanced future relies entirely on a microscopic geological byproduct that actively tries to abandon the planet. This geological lottery has created a rigid geopolitical trap. The global supply is tightly controlled by a small group of nations. The United States extracts 42% of the market's helium, and Qatar holds another 33%. Now, compounding global conflicts are choking these two main arteries. The ongoing trade war, limiting what the US will sell to China, combined with disruptions to Middle Eastern shipping routes, has severely restricted who gets access. 2 decades ago, Indian scientists demonstrated that the country could harvest its own domestic supply from the Bakreshwar hot springs in West Bengal, but that capacity was never scaled up when the market was stable. Today, nations are resorting to new countermeasures. Hospitals are attempting to recycle whatever gas vents from their machines, while governments are racing to carve out massive underground strategic reserves to store every ounce of helium they can buy. global dominance is shifting away from traditional petrostates. Future economic power will belong to the nations that can secure and hoard helium. A moment of wonder. This shrinking supply has forced countries to look beyond Earth entirely to secure their technology. The renewed international space race to the Moon's South Pole is motivated by the prospect of lunar mining. Undisturbed by an atmosphere, the lunar surface has absorbed vast quantities of helium over billions of years. This cosmic scramble connects directly to India's own ambitions, like the Gaganyaan human spaceflight program. Securing the ability to mine resources off-planet is now a key part of the plan for long-term technological independence. Every technological ambition mentioned, from AI to space exploration, now sits on a foundation of helium. In an increasingly competitive landscape, the ability to secure the supply is a baseline requirement for any nation aiming to keep its most advanced systems online.